Hello, my name is Loïc Hoguin, and I'm the Cowboy author. People tend to call me the Erlang Cowboy. I usually have a hat, but this time I didn't bring it. I kind of lost it. I'm sorry. Hopefully next time. So I'll be talking about Cowboy, which is quite popular Erlang HTTP server. It does not only HTTP but also REST and WebSockets. And we will focus this time on WebSockets. So I want to explain how you can easily build a web chat application in Erlang using Cowboy in really a few steps. So let's start. First, we have Cowboy. Cowboy is quite new. It's maybe 2 years old now. It's received a lot of development, including in recent months. It's still a work in progress, but it should be almost ready. In the WebSocket side, it's fully WebSocket standard compliant. WebSocket is now a standard. It has an RFC, we will see it afterwards. And Cowboy has been tested with 1 million concurrent connections on a single Amazon EC2 instance. So that's pretty good, I think. 1 million takes about 25 gigabytes of memory. So that's, yeah, I think it's pretty good. You can really scale your application if you need it. And Cowboy, of course, is getting refined, and we now have a user guide that is mostly for Erlang developers. So I'm not sure how many people here are doing Erlang already, know Erlang. Yeah, not many people. Okay, so that's good. Hopefully, I hope to write a book which will introduce people to both Cowboy and Erlang at the same time, without going too much into details about Erlang itself, since there's already many books. But I see that people who do web stuff and come to Erlang try directly to use Cowboy, so hopefully this should be a good documentation. So WebSocket is a standard. It's mostly it's using the HTTP upgrade to initiate two-way connection between the browser and the server. So it's mostly TCP connection, except it has framing because there's a few types of data packets you can send, and especially two which are text, which is Unicode text. It has to be proper UTF-8, sorry, and binary, which is anything really. And the WebSocket is supported by now all the major browsers, so it's a technology that can be used, and we will talk afterwards about solutions for other browsers which don't have the support. So what is a web chat? A web chat is mostly a few users which connect to a server. The server has one or more rooms, and you can have one user in one room, many rooms, and so on. So it's mostly something that broadcasts messages to users based on the room they are in. So it's not complicated. So let's write a web chat. Okay. Can you see? Oh yeah. Okay. So I'll be starting with the Cowboy WebSocket example, which is just a few files. Here we have an OTP application. I won't go into details. I think Eric talked about it this morning. So when we start the application, we create what is called the dispatch list. It's pretty much the list of paths that will be matched against. And when a patch match, you get a handler, and then this handler is executed. execute.
Can we dim the lights a little bit?
The light. So here we simply have three paths. We have the first one, which is the slash path, which is simply our main HTML file. We have the WebSocket path, which will be our WebSocket handler, the one we are going to modify. And we have one where we store JavaScript files. Here it's jQuery, because it simply makes it much easier to do WebSocket code. And we start a Cowboy listener with these rules, this dispatch list, and this produces the following results. I can connect. There's a few messages sent. I can send messages myself. Okay, and I receive them. So not a lot of things. So you can see the code here. This is all the code that's needed to do this. We have first, we start a timer that will 1 second after connection send the message to the socket, and then we have here this the timeout for the timer. So we start another timer to send another message, and so on. And each time we reply the previous message we wanted to send. And when we receive here a message from the WebSocket, we send it back. So there's one thing important to notice here. We have one function, WebSocket handle, which will receive the messages from the socket, and one function, WebSocket info, which will receive the messages from Erlang itself. So, as some of you can guess, I'm sure, this is mostly a gateway to your Erlang application. When we receive a message from the socket, we will do something on the wrong side and possibly come up with a response. And when we receive a message from Erlang, we will possibly send something to the socket, and so on. So this one here isn't a web chat. We only have one user at a time. We don't have a concept of rooms yet. So we are going to do that. First, let's remove everything about the timers. Let's go to a clean state. Okay. So this is simply echoing back anything we send. We can test it. Oh, yeah, I need to start. So if I send something, it's echoed back. Okay. So now, when we receive this message, we want to broadcast it to any other people in the room. We are going to do a single room for everyone. There's no need to get too complicated here. So we don't need actually to have a process or anything to contain the room messages. We can simply, when we connect, register the processes under a single name, for example, my room, and every time we receive a message, we simply forward it to all the processes, all the connections that are in the my room registry. So we have something that is called JPOC for this. So when we initialize the WebSocket connection, we simply register this process under the name my room. So here PL are simply mean property, that is a list of processes that will be available under this name, and L is for local. We can have also a global registry for distributed applications. And so, when we receive a message from the WebSocket, we simply tell the JProc, my room, that to send it to all the process register. Okay, and here we won't reply. There's no need because we will also receive this message since we are registered to this room. And when we receive this message, so we will receive it here. We can reply it directly. And that's it. We have a web chat. Let's try. Oh yeah, I need something. I forgot. I also need to start the JProc first. No, this is not the right. Okay, now. Okay, so if I send a message, I still receive it. But then if I connect elsewhere, and I send a message, everything receives it. Okay, did everyone understand how it works? We simply have a registry of processes in the room. So here we have our two connections, and every time we receive a message, we send it to all the processes in the registry, which then send it to the client side using WebSocket reply here. Okay. So let's go. Oh. Yeah, high five. Okay, so let's go into more details about different kind of web chats. We have covered the most basic usage, which is one single room. We can have as many people in it as we want, and that doesn't do much. We don't have sessions, for example. Sessions would allow us to, when we have a disconnection, because the Wi-Fi went down or something, and we'll reconnect. We want to have our messages still there. We don't want to lose everything while we weren't here. So a session would be simply an Erlang process which buffers the messages, and this is this process that would receive, that would connect, register the register to the room and receive the messages sent to the room. And then when the WebSocket connection arrives, it tells this process, hey, I'm here, please send me everything you have. And that's about it. And of course, if you have a session process, you can also manage the state of the connection. For example, if the user didn't do anything in the past 5 minutes, it can be put away or disconnected. So, but this isn't all, because when you send a message, you don't always know whether this message got to the client. The client could reply, but replying means you double the number of messages sent through WebSocket, and that's not very efficient. So instead, you simply tag all the messages you send to WebSocket with a number, and this number gets auto-incremented, So when the disconnection happens and the client reconnects, it simply pass this number on reconnecting, and the server knows at which point it stopped receiving messages and sends every seconds. And we avoid checking that it received, since now the state, this part of the state is stored in the client. It's the client that knows about this. And of course, once you send all the messages that it missed, you can just continue as before. And that's it. So thank you. I hope you have many questions. You can find the Cowboy on this link. There's an ERC channel if you want. And you can follow me on Twitter. Any question? Yeah?
So theoretically, like, how many messages can you process at max?
When we tested it with 1 million connections, it was about a message per second. So that's about 1 million messages per second. But we didn't reach the limit. We just tried on this. It's not a small, but it was one of the smallest EC2 instances. We just wanted memory. And actually, you can process really a lot of things thanks to Erlang. But what will be the problem is mostly I/O. You reach the limits there long before Erlang starts consuming too much CPUs, or also the memory. If you are doing a lot of things, you will tend to have many things in memory, and that's also a problem. Any other question? Yeah?
You mentioned an auto-incremented ID, which
Yeah.
is easy to do if you only have one instance of your server. What if you have, could you scale this out?
Yeah. The way you do this in a distributed environment is that the session process, when you start the session process, you start it on the same node as the WebSocket connection. But when the WebSocket reconnects, it might be on a different server. And so you still continue to talk thanks to distribution to the session on the first server. And this process never stops. And this is the process that contains both the buffer and the IDs for its messages. Any other question? Thank you.